G'day and welcome to the fourth video on the binomial distribution. This continues our discrete random variables section. Now I just want to spend a little bit of time on graphing the binomial distribution. To be honest, this doesn't come up a lot in exams. I've seen it a couple of times, but it's not a big part, but I assume that you'll probably be able to understand it eventually anyway. So when we graph the binomial distribution, this simply tells us, down the bottom here is our number of outcomes. So before I was flipping a coin 4 times, so here would be 0 heads, 1 head, 2 heads, 3 heads, 4 heads, and I'm working out the probability of each of these, and that's the y-axis, I guess. So up here is the probability of each outcome occurring. Now what happens is if I change my probability of success, I'll actually change the shape of my graph. Let's stick with the one that I knew in the first place. What the probability that x equals a half, this is the flipping the coin one. I know that the most common outcome that it's going to occur is this 2 tails. Okay, 2 tails and 2 heads is the most common thing that's going to come up when I flip the coin 4 times, and the least common ones are when 0 tails or 4 tails. Okay, so this is the probability measuring over here. This one we call symmetrical. If I had a biased coin, for instance, and all of a sudden it was more favourable of getting a tail now than it is a head, so the probability is now bigger than a half, what you'd expect to happen is that you'd expect for me to get more tails than I would heads, which means it's not unlikely that this distribution would occur. So getting more tails is actually more favourable than getting less tails. So 4 tails is actually the highest one. If it starts to look a little bit like this, so the probability is a half, kind of pushes it the data this way, we call this negatively skewed, because I guess that the tail of it is pointing toward the negative. So this is called negatively skewed. And this one over here, if probability is less than a half, it makes sense that I would, if the probability is now skewed in the favour of heads, that means I'm going to get less tails than I will heads. So 0 tails is actually going to be the most likely outcome. And so this one I actually call positively skewed, because I guess the tail is pointing towards the positive. Okay, you don't need to understand a lot about this, but I guess I would hope that you would be able to see these graphs and recognize what the probability of probability of success is, based on these graphs. And you can probably do that intuitively anyway. Okay, so now I'll move on to finding out some other things of the binomial distribution. So the expected value of the binomial distribution is quite easy. The expected value, or mu, or e of x, or the average value, is just the number of outcomes multiplied by the probability of success. And that sort of makes a little bit of sense if you think about it logically. So n times p is how to work out the expected value of a binomial distribution. To work out the variance, it's actually not too tricky at all. To work out the variance, it's just NPQ. And Q is, remember, Q is the probability of a failure, so it's actually the same as NP 1 minus P. That's how to work out the variance. So again, quite straightforward. And then finally, if you want to work out the standard deviation, we just need to get the square root of the variance, that's always the case in year 12. So the square root of NPQ, or the square root of NP 1 minus P. Okay, these are often very, very handy. The last 2 things I want to go through with you is to work out the median and the mode of the binomial distribution. So to work out the median of the binomial distribution, this is calculated by adding up the probabilities of the outcomes from left to right until the value of 0.5 is obtained. So this outcome is considered the median. This is very similar to the probability tables that we were doing before. Okay, so in this case, I've got the probability table here. Let's just say that this maps the binomial distribution when 5 is the desired number of outcomes, or 4, or 3, or 2, 1, and I start adding them up, and eventually I get when 0.01 plus 0.22 plus 0.15 is only 0.38, but when I add in the 0.37, I end up getting above 0.5. So therefore, 4 is considered the median in this case. Okay, it's exactly the same as when we're doing the probability distributions. Now, the way to do this on the calculator, I don't believe that there's a quick, easy way of doing it on the calculator. I'll keep searching to see if I can. But what I would suggest doing is, getting out all of the outcomes like this here. So just type in your conditions of the binomial distribution, and you should get all of those values there. And then what I would do is I would start adding them up. It's a bit tedious, but you'd have to type in 0.0625 plus 0.25. See what that is? No, it's not over half yet. So plus 0.375, 11 over 16, that's bigger than half, and so therefore that would be my median. So 0, 1, 2 would be my median in this case. Okay, so it's a bit tedious on the calculator, but you can do it like that. Now the mode of the binomial distribution is exactly the same when we were doing the probability tables. So the outcome that has the highest probability of occurring is considered the mode, as this is the most likely outcome to occur. So again, if I look at my probability table and I see that 0.37 is actually the highest probability, therefore that one is the mode. Okay, so that's how we work out the median and the mode for the binomial distribution. So that this video ends our series on the binomial distribution. Hopefully you've been able to understand all of the ins and outs of it. I guess the one thing I will say is that you can still do things like conditional probability and a few other things on the binomial distribution, but again it will be calculated in a very, very similar sort of way. So in the next video that we'll look at, I'll look at Markov chains, which is the last part of discrete random variables. So thanks for watching.